At this point, you should have already completed the top part of your notes outline for today up to the dotted line. If you have not completed that activity yet, then please pause the video now, complete that activity, and then come back to finish the bottom part after you're done with the top. Assuming you finished the top part of the activity, you're ready to summarize what happened with that, which is what this is. So this is going to be a quick summary to wrap up some ideas. So you're supposed to draw a couple of intersecting lines. So something maybe that looks like this picture. Yours might have been going a different way. So yours might have looked like mine, or maybe they might have been a little closer together like that. Those are poorly drawn, but you get the idea, so maybe you had like some acute angles and then some obtuse angles. So it doesn't really matter where you put your lines as long as you had a pair of intersecting lines. And then you had to go through and measure those with your protractor. And you're asked to make some observations. So one of the observations you were asked to make was about the opposite angles. So the opposite angles will be the angles that are across from each other. So angle 1 and 3 or angle 2 and 4. So there's a couple of pairs of opposite angles. If you measured carefully with your protractor, then hopefully you notice that the measures of those opposite angles are the same. So that is an interesting thing that happens when you draw intersecting straight lines, is those opposite angles will always have the same measure. Since they have a special property of having the same measure, they also get a special name. So those opposite angles that you get when you make intersecting lines are called vertical angles. The reason why they're called vertical is because depending upon the way you put the diagram, they are vertically across from each other. So that's where the name vertical angles comes from. So we just said that those opposite angles, if you measured carefully, hopefully you were noticing that they have the same measure. So there's a special word for that we're going to introduce that you're going to see us using as we track through this chapter. So the mathematical or the geometry word for things are the same is the word congruent. So vertical angles are congruent, which really just means the same. But when you're working with geometry, we like to use that word congruent. So we could make a statement about the vertical angles, and so I'm also going to introduce to you some correct notation and some symbols. So if I wanted to say that these opposite angles, angle 1 and 3, are congruent or the same, the way I would say that is angle 1. So the symbol for an angle is literally a little tiny angle. So that is an angle symbol. It is an actual notation, correct notation. And we would say that angle 1. And angle 3. Now, rather than saying equal, when we're talking about geometry shapes, we use something that looks like an equal sign with a tilde or a squiggly over the top of it. So that symbol is a special symbol, and that is what's called a congruent symbol in math. So that means that the two things are congruent or they have the same measure. Usually we reserve equal signs for working with numbers, and when we're comparing shapes like angles, we would use a congruent symbol instead of an equal symbol. So we also have another pair of vertical angles. In this diagram, angle 2 and angle 4 are also congruent. So we have two different pairs of vertical angles. The other observation that you were asked to make was about things called adjacent angles. And we said that adjacent angles are angles that are sharing a ray. In other words, angles that are right next to each other. So there are actually 4 different pairs of angles that are next to each other in this diagram. 1 and 2 are right next to each other. We also have 3 and 4 right next to each other. We could go the other way with that too. 1 and 4 are next to each other, and 2 and 3 are next to each other. So there's actually 4 different matchups of adjacent or angles that are next to each other. So the big observation with that is all of those angles that are next to each other. I'm going to erase this and just focus in on one pair of them. So let's look at 1 and 2. So 1 and 2, if I put them together, those two angles together make a straight line, which means they make a straight angle. And we know that a straight angle is 180 degrees. So I could put any of those different angles together. So angle 1 and angle 2 together would equal 180 degrees. I could say that for any of the other angles that are next to each other. Angle 3 and angle 4 equal 180 degrees. Angle 2 and angle 3 are next to each other, so those are going to equal 180 degrees. Angle 1 and angle 4. So basically any pair of angles that are right next to each other, if you put them together, they're going to make a straight angle or a straight line. So they're going to add up to 180 degrees. So those are the different angle relationships that you can form by intersecting lines. You can form vertical angles, which are those angles across or opposite from each other that are congruent, which means they have the same measure. You can also match up all of the different pairs of angles that are next to each other or adjacent to each other. And all of those pairs of angles next to each other with intersecting lines will always make a straight angle, so they'll always make